Hello, today I want to expand on some of my previous ideas for 3D printing a lens for solar power and how I can thought about ways to make it even better or more accurate. So here's a long list of things I thought about. So always have some experimental backing, but require a lot of development for it to actually work. One is using electricity. Yes, I know I spelled wrong, so let me fix that on my noisy keyboard to fix it in a variety of ones. One is we can use electricity to locally remelt stuff and reshape stuff. This remelting can let stuff flow into cracks or just melt surfaces so they can curve and they'll be less jagged. You could remelt stuff selectively so it's more viscous in one thing. So one place it's more molten than another place, and that can draw it with surface tension and pull it to a cooler place actually, or as it cools it down, pulls it. There's other things you can do with remelting or melting, where you can make certain places of it swell up, or swell up a certain amount, or collapse on itself. The swelling up though can make it more change its density, which changes its refractive index. So with all the swelling up and stuff, we'd have to think a lot more complex. You could also do not fully remelting, but maybe phase changes, which phase changes are much more general thing in physics. But the idea of phase change is that a material changes from one property to another property quite rapidly after something process. So normal phase changes, you might think about like solid to liquid to gas, where you heat it up and for a while it's acting like a solid. Its properties change slightly. It might become less dense as it heats up. It might become more or less thermally conductive. It might lose integrity, but then suddenly it reaches and it slowly heats up. Then it stops heating up for a while. Then it just all collapses and melts. Classic example, ice. Then the same as with water. It just starts heating up, maybe expands a little bit, but eventually it just stops heating up, and then all of a sudden it starts boiling and changes. What phase changes actually it can mean in physics and also in math so much more, and in chemistry. It can, and sometimes other fields they use it, but it can mean, for example, when a building suddenly collapses, that's a phase change. You just keep on adding weight and it acts like a building and the structure's fine until it collapses. That's an irreversible phase change usually because you can't rebuild it. Technically you can, but what it means is if I take off weight, it doesn't rebuild itself. A phase change could happen sometimes in sociology and stuff where suddenly everyone goes from peaceful and quiet to giant riots. But it's just a quick change, but remelting can do other phase changes, and some of these other phase changes could include changes of like crystal structures or how the polymer is formed or something that makes up the lens, polymer or ceramic. And all that could just change how it's shaped or the local properties for how it's focusing light. If it sounds like I'm being vague, it's because these are really all possibilities that you really have to work on specifics. So yeah, it is vague at the states. Polymerization. So sometimes electricity can locally polymerize or not polymerize stuff, and that can make the local structure more dense there and bend light more, or it can make it also contract in places. Or you can just make it have or with it, but also you could put down a layer with regular 3D printing, and then when you need more precise, use electricity to only make the polymerize in certain places for the finer details, for example. Or the remelting technique, you could carve away actually also with the remelting technique, you carve away some of the materials instead of just always placing it down, or for more exact measurements too. Now I did say polymerization, But I do mean more than just polymerization. I could also mean I'm using polymerization because most 3D printers work with polymers, and that's the easiest. But I could mean anything with different types of chemical reactions that could occur in this whole thing that changes the structure. Metals don't really go through it, and ceramics are not really that commonly 3D printed yet. And ceramics do include glasses in my broad category definition. Actually, so do not think I'm disincluding glasses. You can also, with electricity, do the exact opposite of all what I've been saying and cause depolymerization. Now, depolymerization would make it less dense, or you can break it up. You can also have various degrees that it is less dense in a place or more broken up. Now, if you could depolymerize something that's already stuck in place, it can make it more squishy too, since it's mechanical parts, so it squishes down when something else hits it, like the idea of forcing drops before. When it's drops forced, maybe it's more squishy there, so it bends more, collapses, or maybe it's possibly molten, but the whole thing could affect it that way. Also, I just thought about changing the heat settings, so some parts of the material is hotter than other materials. If you use then the force settings too when you place it down, it might change the shapes. Change the shapes a lot. Depolymerization could also work, and again, it could be other chemical reactions, but that's hard to tell. Now, how you can also just make defects in the structures and other things which could increase local scattering, which scattering can actually be used in positive ways in optics, but it's really complicated and hard, and that might not be well controlled, so I don't want to list it as a main point or idea. The other thing that electricity, now how would I put electricity into it? That's also a question. Well, there's a couple ways. One is you could have a very fine surface needle that looks kind of like a spark plug, and this spark plug design would just put a little current through the two ends, and the polymer would be just below it. Another one, that one is very good for surface stuff, and you could design a variety of spark plugs for different surface things. And it's relatively low power, but it might not be the finest detail at times because you have to get the spark plug very close together. And you might have to also hold it very close to the surface, and mechanically moving it that delicately would be very complicated. It also would be very time consuming unless you had many of them, which would be more expensive in designing the whole thing. Another one is you could use electron beams, which actually were used to make, which cathode ray tube is a type of electric beam. It's a low powered one, but it's used to use in old TVs, and how those electric beams would not require you to have anything touching the surface. Would require more power though, potentially more power, because you have to shoot electrons at the surface from a tube, and also you would have to worry about interference from air and stuff and atmosphere if you want to get to really fine details. But you might not need it with the fine details you get to. How electron beams work is basically you put really high voltage and between two plates, and somehow that attracts electrons. Some of it goes from the, I'll just quickly draw it. Let's just do black and 0% fill, and let's make that a reasonable size. If it goes from, some with high voltage goes from a minus to a plus plate, so these electrons just go from here. A lot of them stop here, but some of them just keep on going because they have so much energy, because they'll accelerate so much. And there's a lot fancier ways of doing it, a lot fancier plugs, and you can use magnets and other electric fields like magnets around here, and other electric fields to focus them to really fine points to carve stuff, and everything in between. So that's basically how the electric beam things can work. Another way you could do it is you could just send electricity down to the whole material from one thing to another one, which you could combine more easily with like the spark plug idea. But the problem is that that can give you very precise in this direction XY, but not very much precise in the depth direction, unlike the spark plug, which gives you more precise in the depth direction. And it also has the disadvantage that as the material gets thicker, you lose more electricity. That's so yeah, a lot of disadvantages. Oh, besides electron beams being this, you can also accelerate electrons using radio waves and microwaves and other radiation, which is more complex, but it's based on those radiations have electric and a magnetic component to them, which can help accelerate stuff. Another idea you can have is just surface melting of the materials. And the idea with, I've discussed it before, don't like how it turns a different one, but we can melt the surface of material more precisely with a variety of things, such as afterwards having a needle or a small device that just locally heats up and melts it in a very, very precise. We can make needles now that are one atom, literally, one carbon atom sized. We will, of course, do this because one atom will be just way, way too delicate in that needle. But I'm saying we can get to atomic scale with surface melting. And with that, also, it's not only, we don't have to completely melt the surface, just to deform it somewhat to different extents. And you can also even make needles, which I did not put here, but now that I have the idea, is you can even have small needles that move material around a little bit. The material sticks to them and just draw it out here and there. I want to add that. And that resizes everything. But needle to move stuff. There's other ways you can do it. You could do blasts of superfine focus blasts of actually hot gases and stuff, which have been used by some people to do microscopy or locally heat up stuff, but I haven't heard about that being a very developed technology in printing or forming stuff with the needles and stuff, and is something that's already been done. So that would have to be a lot more developed. Or you could locally heat up stuff, not with spraying other chemicals just locally there that just transfer heat really quickly or not. Or if you want to use local heating and surface melting, you could make the material slightly magnetic at different places and heat up using a small magnetic field that oscillates, and then whenever stuff changes its magnetic field quickly, it heats up because stuff is flipping from one direction to another direction. You know, like a magnet has a north and south one, but when it first aligns north, then it aligns south, parts of it, and that all just caused off energy loss. It's actually induction heating on the stove. That's one way it works. Well, one of the most common ways. It's also used in a lot of giant ovens to melt metals, usually. Using metals because they strongly interact with magnets, and the advantage is you don't have to touch the magnets to melt them. And also you can melt them more as one big chunk at once than melting just the middle, than just melting the outside and slowly melting the middle. And I meant to write needle. Today is just a great day. So needle to move stuff, or you can make other shapes to move stuff just along the surface, pick it up too, or stretch it out, or just punch it in maybe. So another idea I have would be wetting and anti-wetting agents. So, briefly, you can use a bunch of things to make increased surface tension locally or decrease surface tension, or at the interface make the interface more or less stable chemicals. You would have to play around with these chemicals, and you might need to wash them off in between, but they could help. And if you increase surface tension, you start making more of a meniscus or a round curve locally, and you get it to fill in more cracks and smooth out stuff. If you make it have less, it more collapses to a flat structure. And actually with surface tension, you kind of get three opposite structures. And I will draw that quickly once I get to a pencil. If it's fill 0, black. If whatever material, if this is a beaker, and I can draw the liquid in a different color. Let's make the liquid purple. If the purple liquid more strongly interacts with itself than the container sidewalls, which we could do, then it becomes, or the other material, then it has a positive one because it kind of bunches up on itself. Positive, so it goes up. The more it goes in the middle, away from material. If it interacts with the sidewalls more, then it goes down. If it has zero interactions with itself and the sidewalls, it's just flat. And there's all sorts of other shapes, but we can add materials to make it more or less surface tension. For example, salt water, liquid. Add salt, it has more surface tension because all the positive and negative charges. Add soap, it has less surface tension. And that can lead to all different effects. It also has less surface tension with walls and stuff like that. Another idea I have is using ultrasonic waves to either locally heat or melt some parts or collapse parts. Now, ultrasonic waves can also move. Ultrasonic waves can even move stuff a little bit. If you ever seen a droplet and if you start shaking the droplet might start moving away from where you're shaking most, because it's moving from a high energy place to a low energy place. So if it's shaking mostly on this end, it's going to go away from the source of the sound. And sound can spread out stuff. It can disrupt surface tension because surface tension is based on the film, and if the film is going up and down enough, the film no longer exists. Now the thing about ultrasonic one is it's not a super precise, it's precise but it's not super nanometers precise that I would really love by far, because those waves are still a lot bigger than light waves. So it have to be secondary effects of like that get squished because of surface tension or something. Another thing that I want to bring up for idea is getting this whole thing to spin or move. I don't like this idea as much because it would disrupt a continuous production setup as I see it, which I do not like at all, but it could work. And how that would work is, for example, let's say I just print out one circular mirror, and before I said that a long rectangular one with a linear focus. So linear focus is it doesn't focus on the spot, it focuses on one line. It would be better because you can produce it more continuously. You don't have to stop and cut out little seeds and all these other advantages. But for this one for spinning, you would have to make this one circle. And then you would take that, and circles also do not fit as well together in your big solar fields. Unless you cut off the sides and make them squares, but then you lose material, which I do not like, and then you can recycle material, but the more you process and the more complex the material structure is, if you do all this other stuff, it might be harder to process. and melt, and especially if there's like different chemical compositions everywhere, and you have to separate out the chemicals or something, so it might end up in some later secondary use. But anyways, if you have a circle and you spin it just right, you can take some of the bubbles and maybe draw them out so they start stretching. Now, with a lot of things, when they spin and they tend to get the opposite shape you want. But that could work out if they tend to get high on the sides where it's moving faster and lower. That could work out actually if you want high on the side. If you look at the reverse, and it's gonna make a disc like this. And if that's the material that interacts more with the spin, is the one with the higher refractive index, that would leave the lower refractive, the higher refractive index, to be fill in the gaps of where and have the right shape instead of the reverse shape that's bad. The problem with that technique that would have to work out is, even though this might seem nice, spinning it, things with higher refractive index tend to have be more dense, and that wouldn't be the thing that would take off and fill in the gaps. It would end up being the worst, but not always. You could engineer something that it would work like that, definitely, but it's a lot more complicated. I could see some ways. I mean, you can make this a higher refractive index by using two different materials. Definitely not the same material, but in a more dense form. You could add impurities or something to increase it, or more prancing or other things. Yeah, or there's other ways you could maybe make stuff collapse. Instead of rotational accelerations, you might figure out linear accelerations that work by stretching it to make certain structures collapse. Or you could stretch out the whole material and make bigger details smaller in some directions, such as, let's say this block is I drew two blocks on the bottom. Let's say if you take a block and it's 20 high, then 10 inches tall, 20 inches high, 10 inches tall. If I stretch it out twice as much, it might get 20 inches long and only, 20 inches long and only 10 inches high or something like that. Like, yeah, you can just change it. You would have to figure out how to stretch it out just right, that it actually moves and everything collapses to be more structured. Because when you stretch out in one way, you increase the dimensions one way and you make them small in another way. So that makes the whole thing. It might need that you need to print, to make details in some places. You melt it, and you could combine this with remelting or something like that, where you make certain parts of it more stretchy or not, and you only to cause it to stretch out in just the right shape after you stretch it out. But that's all complicated computation. It might be more time consuming and material-wise, and might lead to more defects and less control. But I am putting out those ideas. The spinning and moving can also be controlled by just remelting only certain sections or controlled melting. More materials. Having more materials with different refractive index, different interactions and melting and interfaces could potentially give you finer details, because you're looking at other ranges. Something else you could do is you could take the droplet that's big, the 3D printer is sending, and split up into many smaller droplets and spray it. The spray itself is not as controlled, but has many small droplets. But by overlapping sprays, there's ways that with algorithms you could potentially get finer detail, but this will require a lot of expertise to design it. But all electrical spray systems like this. you could use a mold that's made first with a lot finer details to accomplish all of these ideas. But molds can be very hard to design and actually control. And you require many, and if there's a problem with one of your molds, it gets into all of them. You have things afterwards. So mold is not a perfect answer. Another thing you could do is figure out ways to make it heat up or destabilize at the interfaces of two materials specifically, because they either have different electrical properties, magnetic properties that causes localized energy. You could have them have other different chemical properties. Chemicals could interact and either chemically react surface catalyze or at the surface stuff can melt more easily, because sometimes the interface between two chemicals melts more easily, sometimes harder, but usually if the two chemicals can dissolve each other, they melt more easily together. And the reason why that is something called a eutectic. And a eutectic is any time when you mix two materials and the melting point is lower than both of them. And that can happen for many reasons, but all salts have some structure to them. And when you have more materials mixed together, the simplest explanation is that it's hard to get that structure because you have to organize more things, which makes it harder for it to become a solid. That is a very brief overview. There's a lot more nuances to it. Another idea is to put a mirror on the bottom of this. This does not actually solve a lot of the problems that I just mentioned, but you can have to print out only half your lens because it's focusing twice. It's focusing as it comes in and as it bounces off from the mirror. So you have to print half the amount of material. Another advantage of having a mirror on the bottom is that you can face the solar panel above the whole thing, and then the solar panel can collect light from unfocused that hits it from without being blocked by the lens, so it can collect more scattered light just above it, and I will just above it on the actual solar cell, and then it also scatters some of the scatter light below it, and you don't have to clean the solar cell also and the lens, because the solar cell is kind of upside down, so it's not going to get as dirty as much. Now you only have to clean the lens. Before, both of them were right side up where the light came in, and you have to clean out both. The last idea I want to go over would be laser etching or laser polymerization stuff. At first I said no to this idea because lasers use light. Surprise, surprise. And light would limit the amount of detail you can to usually to wavelengths bigger than everything we're talking about. So we want to have scales smaller than the wavelength. Now, light, there's tricky ways of doing it, but it's very, very tricky, very hard, especially when you have a bunch of when you don't have one single photon, you have a bunch of photons. But it could add some details, and the way you could also, but actually the main reason why I said no, beyond that, is that also lasers would have to strongly interact with the material to really do it well. And if they interact strongly and absorbed by the material, they don't make a good lens. You don't have something transparent. However, we could use the lasers to help with some ideas for the final details. Not fully, and use other ideas to put the end goal. And these lasers could instead modify a liquid or something above it that does all the actual chemistry and not the material below it. And if you use a laser of a UV red, UV, high UV, then you only can't really use UV light, well, at that detail. But the other methods might compensate for that. Well, thank you very much for listening. Please like and subscribe. It really helps the channel out. And leave a comment below. Thank you very much.